Attracting tomorrow. TDK.
Okay, we're here to demonstrate TDK's Xilinx reference design on the Zynq 7 SoC. We actually have it displayed here with the Zynq 7 system on module card. This is the Zynq 7 with 3 of TDK's micro-point load power modules on the board, as well as a simple sensor carrier board with our collaboration partner, Concurrent EDA, and also a little display here on the right actually showing some sensor data. We'll go ahead and do a quick demo of this, the sensor fusion board, in a second. Just wanted to show you a little more closer view of the system on module design that we've done here with the Xilinx Zynq 7 FPGA. This is the actual Zynq 7 here to my left. And then you can actually see here, right next to it in very close proximity, 3 of TDK's chip-embedded micro-point of loads showing power supply for the core rail, the VCC aux rail, and the system rail. They're also separated by 6 millimeter spacing, and this was actually enough spacing to handle the thermal performance of the device, which we'll show here in a moment. But here's kind of the top side of the Xilinx Zynq 7 SOM card to show a miniature design of the SOM card with TDK's power modules. And there's the back side of the card as well. And so this SOM card actually fits onto the carrier board as I'm showing you here. We just have a simple demo here that allows you to attach 2 PMOD sockets to attach any sensors that are currently available as part of an ecosystem. It also includes a TDK standard connector as well for sensors, which we'll demonstrate on another video. But we also had some TDK sensors on there as well. And then finally to the right you can see the display. And what we're showing here now is we've actually got a temperature and humidity sensor. You can see that it's actually increasing as I touch the sensor with my hand. Just wanted to show you that real fast, that we actually have a full sensor fusion system with Xilinx's Zynq 7 in a very small form factor design. All right, some details here now, a little bit more about the actual power design of the micro Zynq 7 module. We're going to go over some of the schematics and look at the VCC int rail, the VCC aux rail, and the main 3.3 volt supply that's also used on this micro Zynq 7 module. Here's the actual schematic of the VCC int rail of the Zynq 7, and what I'd like to take note of is the simplicity of the power module design. You just add your capacitors and you're done. We've got the integrated inductor, and then you end coming through the I2C ports and actually programming the output voltage. In this case, we can actually tune the design for 1% DC, 2 to 3% AC accuracy, and also for even SerDes rails well below 10 millivolts peak-to-peak ripple. In fact, we've seen 2 to 4 millivolts peak-to-peak ripple with this standard output capacitance. And as we go on to the VCC aux rail, you see the same thing, the same simplicity of the design. You add your capacitors and you're done. And then finally, the 3.3 volt rail we use in the micro Zynq 7 design as well. Simplicity of power modules. So one of the key advantages of TDK's micro-point of loads is ease of design. Now let's go ahead and move on to something more interesting, which is thermal management. The question is, did we compromise on the thermal management by bringing the modules too close? Here's the actual thermal image of the Zynq 7 running the sensor fusion card. And actually, if I remember correctly, it was somewhere between 45 to 50 degrees rise from the Zynq 7. More interesting, though, is looking at the power circuits. So I wanted to show you the FLIR thermal charts now of the power circuits. This is actually all 3 micro-point of load modules separated by about 6 millimeters of spacing. And what I'd like to highlight is that TDK's micro point of load is best in class in terms of performance and current size and density. It's got a very special thermal package design in this micro point of load device. I'd like to show you what that looks like here in a second. It's called the C-sub package, semiconductor substrate. This semiconductor substrate allows us to do 1 watt per cubic millimeter of thermal dissipation through the bottom of the board to the center of this thermal path. So best in class in terms of packaging and thermal technology. So this gives you kind of some of the features and benefits of TDK's micro point of load. Thank you for attending this presentation from TDK.
Attracting tomorrow. TDK.